Hey everyone, I'm Antonia Jaramillo with NASA Communications, and we are here at the Kennedy Space Center in Florida. Thank you so much for joining us today. And welcome to our What's on Board show, where we will get to speak to some of the principal investigators of the science experiments that are being flown up to the International Space Station for NASA's and SpaceX's CRS-22 mission. This will be the 22nd Cargo Resupply Services mission that will send technology demonstrations and research to the space station. Here are some of the science experiments that are being sent up. We have some more exciting science to tell you about on board CRS-22. The African Republic of Mauritius, a small island nation in the Indian Ocean east of Madagascar, will now become a spacefaring nation. A team of scientists developed the CubeSat after winning an award from the Japanese Aerospace Exploration Agency in 2018. The satellite will deploy from JAXA's Kibo Cube. Called Mearsat-1, it has a 3D camera on board, which will take pictures of the region. The team developed the mission to help inspire young people to pursue future space and satellite technology. All our participants, including myself, have been fully vaccinated. Now with us today, we have Dr. Jamie Foster, Principal Investigator for the Umami experiment. Dr. Thomas Boothby, Principal Investigator for the Cell Science 04 mission. And we also have Joe Blair and Jonathan Bonamart, students from Oak Ridge City Schools in Tennessee, who will be discussing the Ramsat, which is a CubeSat on board the rocket. Jamie, Thomas, Joe, and Jonathan, thank you so much for joining us here today. Now, before we begin, for those of you watching, you can make sure to ask questions using the hashtag AskNASA on social media. Now, Jamie, can you tell us what exactly umami is? I mean, I'm seeing a squid there. What is this experiment?
Well, this project's all about trying to understand how the effects of microgravity is impacting how beneficial microbes and animals talk to each other. And we chose the squid. We're sending these tiny squid into space to understand how the bacteria are actually colonizing and initiating a conversation at the molecular level with these animals.
Wow. Now, Thomas, can you tell us a little bit more about the Cell Science 04 mission? I mean, I'm understanding there is something to do with water bears. What's going on here?
Absolutely. So our project is looking at how these tiny little microscopic animals called water bears or tardigrades are able to cope with the stresses of long-term space flight. And we're using these animals because they're some of the toughest animals that we know of. They can survive being dried out, frozen, heated up past the boiling point of water, They can survive thousands of times as much radiation as you or I can, and they can survive space flight and even exposure to the vacuum of outer space.
They sound like the ultimate survivors. Now, for Joe and Jonathan, can you tell us what the RAMSAT is?
So the RAMSAT is a CubeSat sent up by Robertsville Middle School in Oak Ridge, Tennessee. This will be one of the first satellites ever to be sent up by a public middle school.
So the mission of our satellite is that we're looking at the regrowth of wildfires in Gatlinburg and California. So the ones in Gatlinburg were about 4 or 5 years ago. So those are almost done, but we hope to still get a cool picture of the regrowth there. And so the way it works is infrared light on the camera. The plants pick it up as white light, and anything that's not living is like dark and black. And so basically, when we take the picture, you'll be able to see white, like a black and white image, but all the white will be life. So basically, if there's a forest fire, you'll see a nice blob of darkness. And then the point is you keep going around the earth until you can take enough pictures and you can put them together, and it'll look like you'll see the life going in and working itself out.
So we created this satellite with scientists from our national lab. If you'll show our video, we have created this using parts from Nanoracks as well as Pumpkin Space. And this is the assembly of our solar panels.
Here, one thing I really enjoyed here was that everybody got to learn how to solder. And so in this clip, you can see we're putting the solar panels on. And this specifically is where we're soldering the wires together. And then when you see the heat gun, we're putting heat wrap around the wires so it doesn't short anything out.
So along with our mission of tracking the forest fire regrowth, we also hope to build curriculum for other middle schools and schools around the globe to create satellites and become more invested in space, like all of our students are.
I think one thing about our satellite that's really cool is that it's not going to just be about the mission. It's going to be about people be able to go into the class and say, oh, cool, I'm communicating with the satellite that's up there in space that our class sent up. And that's how they're going to learn, is based off of all those different sciences. There's camera sciences and electronics and all this stuff that goes into it. So anybody who takes the class can be like satisfied by the different types of sciences in there, and everybody can learn something from it.
Absolutely. I mean, it's a big team effort. Now we have already our first questions from social media. One mom is asking, she says her son, who is 9, would like to know how you transfer items to the space station safely. He's concerned the air will leak out. I think maybe that question's for you, Jamie?
Well, that's a great question, actually, and it's a very important, and we spend a lot of time making sure our experiments are triple checked, and one of the ways that we do that is we do leak tests. So just like that student asked, we have, for example, in my case of the Umami mission, we have the tiny paralarvae or juvenile squid that are going to go in these little bags that have these valves that will allow seawater to kind of move into these environments, and we don't want them to leak. So what we do is we do a whole series of checks where we do pressure tests and we check to make sure that there's no leaks so that the squid have plenty of water for the whole duration. And so that's a really important question, and we do practice these kinds of experiments all the time to make sure that all of these components of the space hardware are intact and ready to go.
Very important. You know, I understand you've been working all last night and still have tonight to work to make sure that everything's good to go. Is that correct?
Absolutely. So, for example, the tiny squid that we're going to be using were hatched at 1:30 this morning. So we've been processing and getting them together and putting them in their bags and into the hardware, and that's taken a few hours. So we're still in the leak test phase, but we are about to turn it over to SpaceX.
So soon. Now we have a question for you, Joe and Jonathan. How do you feel knowing that your CubeSat is going to space tomorrow?
Honestly, I really think it's really cool that something we've been working on for the past 6, 7 years is finally going up. I know about a year ago we were going to send it up and there was a short in the microprocessor, so we got delayed a whole bunch of time now. But it's about time now. We finally get to watch it. And one thing is we haven't seen a launch before, so it should be really fun.
Yeah, I feel ecstatic knowing that kids from Robertsville who have gone on to be even sophomores in college now can see their hard work paying off, starting from just an idea to actually a satellite going up into space.
Oh, absolutely.
If you see here, here's another video of students working hard on assembling the satellite.
That's great. A long time in the making, for sure. Thomas, we have a question for you. How did water bears get their name?
Oh, that's a great question. And I think we actually have a video of a water bear, if we can play that. But yeah, the first time that they were discovered, the scientists that saw them thought like that they sort of walked and stepped like the gait of a bear. And since they're aquatic organisms, water bear was the name that he settled on. And their scientific name, tardigrade, actually means slow stepper. So here's just kind of an enlarged image of a tardigrade that you can see there. But that's how they got their name.
Slow stepper. I like it. Jamie, we have a question from our NASA social group. Have these symbiotic squids been to space before? If so, what did you learn?
Yes, they have been to space. They went to space on the Space Shuttle Atlantis and in 2011. And what we learned from that experiment was that the squid is probably going to be a really good model for looking at how early dialogues between microbes and animals start. So when the squid, and we have a couple photos, there's a video right now of the squid hatching, and so when they're born without bacteria. And so when they flew before, we learned that they can colonize, that even in microgravity, you can have your proper symbionts, your beneficial microbes, find where they're supposed to go. So they were able to colonize, the squid has a special organ called the light organ, and the bacteria colonize this light organ, and they're luminescent, they're bioluminescent. So the squid has the ability to glow in the dark. So the squid uses that as an anti-predator behavior. And what we learned from that first mission 10 years ago was that the squid is going to make a great model because the bacteria do find where they're going, and they can initiate the colonization in the space environment, and we can track that and we can follow that. So that's why we're going again and looking at a little bit more deeper questions about the actual processes, the fundamental processes of how the bacteria are starting a conversation with the animal tissues. So we're building on those previous experiments from 10 years ago.
Ooh, that's very interesting and also a long time in the making. Joe, Jonathan, another question for you. We want to know how many students worked on RAMSAT?
So a total of 93 students have worked on RAMSAT, and this includes former Robertsville students to current 8th graders. So all the way from sophomores in college to 8th graders have worked on this project, set up the ideas, given presentations, and help make this dream become a reality.
Yeah, one thing I remember about working on it is in class at first, it was just all the presentations like, what does the magnet torquer do? What does the solar panels? What do all those things do in the satellite? And so we all learned about it. And so all these videos we had after school time that we all just went in and worked on the satellite. All these were from after the first delay that we had, and so I just remember going in at all those after school times and helping to work on it. I think that was really cool.
Yep. And this was all done thanks in part to our 37 mentors who worked hard hours to help us bring this idea to NASA and help get this satellite up there.
Absolutely. And I believe you also have the names engraved of all the participants. Can you show us that?
Yes, here in our ballast, we have actually the names of every student who's worked on it. And on the side, we have the names of all of the mentors, as well as the name of our ramsat. This is one of our ballasts. The actual ballast is on the ramsat in about the middle. So all the students who worked on it will get their names in space.
That's awesome. You can officially say, I have had my name fly in space. Thomas, we have a question from Twitter. Can water bears survive on Mars?
That's a great question. I think they've been shown to survive in the vacuum of outer space, in sort of a ametabolic or a state of suspended animation. So, I think if any organism or animal from Earth could survive on Mars, tardigrades would be a great candidate.
Well, that's good to know. Jamie, why do humans rely on microbes?
Well, microbes are essential for all parts of our normal development, our behaviors, our physiology. We live in a microbial world, and we have more microbial cells in our body than animal cells. So we rely extensively on how that we understand how these microbes are communicating with our bodies. And so that it's critical for us to ask these fundamental questions of how do you build a symbiosis? How do you start an association with a beneficial microbe? A lot of people focus on the pathogens, but most of the microbes that associate with our bodies are good for us. They're beneficial microbes. And so we're trying to expand our knowledge about what all microbes are doing with the body and how the space environment might be impacting positively or negatively on those associations.
Right. I mean, do you have any idea on whether or not the space environment does have a positive or negative impact?
Well, there are a lot of studies to show that microbes do change their behavior, their physiology in space. And so a lot of the work, well, in the case of the squid symbiosis, we have a lot of ground-based studies, and now we want to validate a lot of our hypotheses by flying them in space and seeing if our ideas that we have on the ground or our results from the ground are going to actually be validated in the space environment.
Well, let's hope.
Yes.
Joe, Jonathan, how will your CubeSat generate energy as it orbits Earth?
It's actually pretty cool. So the solar panels on the outside, whenever it's in the sunlight part of the Earth, because it's going, like 17,000 miles an hour. It's really fast. So a day goes by really fast for it. But in those few minutes or hours of time, whatever it takes for it to be in the sun part, the solar panels charge the battery. And this is a real version of the battery here. And it'll charge the batteries and power it if somebody happens to send the request to take a picture. But if it's in the dark, the battery's charging it, or the battery's powering it. So it's this big cycle of when it gets into the sun, the solar panels are charging it, and then it just cycles.
We can actually monitor the amount of voltage that the solar panels are producing through the solar cells and the flight computer that's on our satellite.
Cool. Will you guys be one of the, students or that will be observing or monitoring that voltage once Ramsat goes up in space?
Yeah. One thing we were talking about the after-school meetings. I think we're still going to do those, and one cool thing we're going to do is keep checking all those telemetry values, like for one thing, the Ramsat sends out a beacon like all satellites. If you know Sputnik, everybody knows that satellite. It has the recognizable like beep, and that's the telemetry being sent out, like the battery voltage and where it's at.
Neat. Thomas, we have a question from Facebook. Is this the first time water bears are going to space?
It actually is not. So water bears have been up in space before, and we know that these really tough, robust animals are able to survive not only space flight, but also in the vacuum of outer space. But what we don't know is how they're doing that. So one of the things that our mission is looking at is how these really tough, robust animals respond to being in this really stressful environment for a prolonged period of time.
I understand your the main experiment is to figure out how they're being able to survive. Do you have any ideas, any preconceived maybe?
Yeah, so right. So one of the sort of two main stressors during spaceflight are microgravity and increased radiation. So we'll be looking to see what genes, what parts of the animal's DNA they're turning on and off over time as they experience spaceflight. And so, for example, we would suspect that things involved with, DNA repair or other mechanisms for coping with, say, increased radiation would be upregulated or turned on more by these animals to cope with those sort of stresses.
Ooh, well, that'll be interesting to find out. Jamie, I heard your handover or turnover. It's happening tonight. Can you tell us a little bit more about the last minute preparations that are needed before you can send your experiment up to space?
Absolutely. So the animals are very young. They just were hatched about 7 or 8 hours ago. And so we are trying to prepare them by putting them inside their little flight hardware here, these little bags, and we're getting ready and assembling the hardware as we speak and doing leak tests, as we mentioned before. And so all of that will be done in the next couple hours, and then it'll be traveled over to the SpaceX rocket and put into the flight hardware will be put into the rocket, and it'll be ready to go in a couple hours.
How does it feel to know that you are so close to kind of giving away, this experiment that's sort of your pet project?
It has been a long, as we talked about on the shuttle flight, it's been 10 years since the last, and it takes a long time to kind of make sure everything's right, to get your scientific ideas validated and checked, and so it's a long process. So it's very rewarding and very exciting to know that we're just hours away now from actually seeing some great science happen up on the SpaceX and on station.
That's very exciting. I can only imagine you are very much looking forward to launch tomorrow. Jonathan, now we want to know, how big is the CubeSat or Ramsat exactly?
So our Ramsat is 100 millimeters by 100 millimeters by 200 millimeters, or to put it in imperial terms, 4 inches by 4 inches by 8 inches.
One thing we were talking about, if you want a comparison to that, it's basically the size of a little milk jug, one of those half-gallon ones.
It's a very small satellite, but it performs all of its functions to the best of its ability, and we're excited to see it go up.
This is a one-to-one scale model, if you're wondering.
That's awesome. Jamie, Ashley from Twitter is asking, her 3-year-old cousin wants to know why baby squid glow in the dark.
So the bacteria, they have a special relationship with a bacterium called Vibrio fischeri, and the Vibrio fischeri is the powerhouse behind the glow-in-the-dark squid. It's a bioluminescent bacteria that is found normally in the environment, but it only starts to glow inside the squid when there's enough of them growing inside the light organ here of this squid. And so once the light is generated, the squid actually uses it as a way to hide from predators. It can act like a cloaking device so that the squid casts no shadow in the water, and any predator looking up can't see the shadow or can't see the squid. So it's a very important symbiosis for the animal to hide itself and protect itself from predators.
Wow. I can only imagine if humans had that same.
Yes,
we'd
it's
all be glowing in the dark.
Harry Potter cloaking device
Yeah.
right here.
Exactly. Thomas, can you tell us a little bit more about why spaceflight is considered such a challenging environment for organisms?
Yeah, absolutely. So organisms like ourselves that evolved here on Earth are used to the conditions here on Earth. So we are used to the gravity that we experience here on Earth and the relatively low levels of background radiation. But when you go up into space, you're in a microgravity environment, and there's much more radiation. So organisms that aren't used to that, that can be an extremely stressful sort of environment. And so by understanding how these really tough little tardigrades are able to survive in those conditions, we're hoping to be able to develop strategies or countermeasures to safeguard astronauts from those stresses.
Well, that's good news. I know I'd like to go to space one day. Joe, Jonathan, we have one more question for you. Will Ramsat stay in space forever?
No, unfortunately, about 12 months, 12 to 14 months is about how long it'll last in space until it just disintegrates in the atmosphere. But we should be able to get a whole bunch of use out of that.
That's great. Now we have one final question from social media for all of you. Where will you be watching the launch from tomorrow? Jamie, if you want to go first.
I'm going to be at the VAB, the Vertical Assembly Building, just right across the road here. So I'm very excited about that.
Are you going to be on the roof?
I don't, no, not that I know of, but I will talk afterwards.
Joe, Jonathan, if you guys want to go next.
Our group that we were building the satellite, our whole group is going to be at the Jetty Park to watch it.
I'm going to be with Jonathan, so.
Yeah. That's a great viewing location. And how about you, Thomas?
Well, I was hoping to get to Florida, but I think I'll be watching it online, but enjoying it nonetheless.
Well, you can make sure to watch our live coverage tomorrow. Well, thank you all so much again for sharing the science that you will be conducting for this mission. And thank you to everyone who was watching us today. For those who want to learn more about the science that's being sent up to the space station, you can go to nasa.gov/ISS-science or follow along on social media at ISS_research. You can also join us later today at 1:30 p.m. for our pre-launch news conference. Launch is tomorrow at 1:29 p.m. Eastern Time here at Kennedy Space Center's Launch Complex 39A. Live coverage will begin at 1 p.m. at nasa.gov/live. Thanks again, and we'll see you there.